Hello my dear students, once again welcome to your online class. Today we'll be discussing about the fourth chapter of your physics textbook, that is the pressure. So before starting this chapter pressure, first you must know what is the force and the thrust. Almost the force and the thrust, they resemble the same thing, but the basic difference is the force can act on a body from any direction. Okay, just like if you have a top of a table and if you have kept a block, okay, I can apply a force at any angle, like at an angle of 45 degree, or I can apply an angle of a 60 degree, okay, or I can apply it an angle of 90 degree also. So of all of these forces, the force that acts at an angle of 90 degree is known as a thrust. So thrust is the force that acts normally on a surface. Normally in the sense, if you have a tabletop, okay, and then if you apply a force vertically downward at an angle of 90 degree, then that force is said to be thrust. Okay, so you can simply say a force is also a thrust is also a force, but the basic difference is the force can act at any angle, but whereas the thrust is that force that acts normally on the surface. So after having discussed about the thrust, then comes the second term, that is the pressure. So you must have realized what is a pressure. Okay, so it's not about the mental pressure. Here we are talking about the physical pressure. So imagine yourself that your mother is wearing a pencil heel and your father is simply wearing a casual shoe. So both of them, they step on your leg. So which one hurts you more? Obviously your mom will hurt you more. Why? Because the area of contact is very less in a pencil heel, but whereas in a flat heel the area of contact is large. So depending upon the area of contact, the same force, it can have a different effect on a given substances. So the force per unit area, or the thrust acting per unit area, is simply known as the pressure. Okay, so the pressure is the thrust per unit area, or simply it is the force per unit area. So what is pressure? The pressure is the force per unit area. So now, since the pressure is also a physical quantity, so there is a unit to express it. So the unit to express it can be simply derived. The expression of the unit of thrust is Newton and that of area is a meter square. So therefore Newton per meter square is the SI unit of pressure, which can also be termed as a Pascal. Okay. So now if you are asked to define what is 1 Pascal, or if I say, or if somebody pinches you with a force of 1 Pascal, what does that mean? It means that when a force of 1 Newton is exerted on an area of 1 meter square, then the force is said to be 1 Pascal. So there is a smaller unit as well. What is it? It is the CGS unit of thrust of the force is dyne, and then that of area is a centimeter square. So the dyne per centimeter square is the CGS unit of pressure. Understood? So now coming to the factors that affect pressure. So looking at that expression, since we have the expression P is equals to F divided by A. So the two factors on which the pressure depends are, one is the force and the second one is the area. Okay. So now how does it depend? Since the pressure is directly proportional to the force. Okay, so the greater will be the force, the higher will be the pressure. And coming to the area, the smaller is the area, the greater is the pressure. So the pressure is inversely proportional to the area and the pressure is directly proportional to the force applied. Okay, so you can simply understand this with the help of an example. Like if I poke you with this marker, it doesn't hurt you more because the area of contact is large. But if I poke you with a pin, okay, so it hurts a lot because the area of contact of that pin is very small. So the smaller is the area, the higher will be the pressure. So now the next topic is the pressure in a liquid. Okay, so what is a pressure in a liquid is, imagine yourself inside a swimming pool, okay, a deep swimming pool which is fully covered with the water, and you are in the base of the swimming pool. So the liquid exerts a pressure because when you are at the bottom of the swimming pool, it is as if you are carrying the lot of water on top of you. Okay, so because of the weight of the liquid, it exerts a force per unit area on your body, and that is known as a liquid pressure. So the liquid pressure is nothing complicated, but it's just the weight of the liquid. The force exerted due to the weight of the liquid is known as a liquid pressure. Now coming to the facts about the liquid pressure. So there are some of the facts about the liquid pressure. What is it? So I simply suggest you to remember one expression that will give you the three facts. Okay, so coming to the fact, I simply P is equals to H, rho and G. Okay, this expression you'll learn when you'll go to class 9, how to derive it. Okay, so here H represent the depth, the rho represent the density of the liquid, dN, density of the liquid, and G represent the acceleration due to gravity. Okay, so the first fact is the liquid pressure depends upon the depth. Okay, so the deeper you go, the higher will be the liquid pressure. The second one is the density. Okay, so the liquid pressure is directly proportional to the density of the liquid. So that means if the density of the liquid is very high, okay, even at the same depth, the pressure exerted can be higher than the pressure exerted by the liquid of a lower density. And the third is the liquid pressure increases with the acceleration due to gravity. That means the liquid pressure on the earth is much more higher than the pressure in the moon, because in the moon the acceleration due to gravity is quite less. Okay, so apart from these three facts, there are some other facts as well. Okay, so one of it being the liquid also seeks its own level. Okay, so the liquid seeks its own level. It means that if you have a container which is fitted with a different shape of pipes, okay, like first I have a curve, then I have a zigzag one, okay, and then I have this kind of shape. Okay, so what now the liquid seeks its own level means that if you fill this container with a water, okay, or any kind of liquid, the liquid will flow throughout the container and will attain the same height in every of the pipes, irrespective of its shape and size. Okay, so these facts about the liquid pressure, you can easily remember it from your book. So the next topic is the atmospheric pressure. Now just like the liquid pressure, now the liquid pressure acts when we are inside a liquid, but we are always it's rarely that we go inside the liquid, but we are on the surface of the earth, okay, which is completely covered by air. The layers of atmosphere are on top of it. So this air or the atmosphere, it exerts a pressure on us continuously. Okay, so due to the weight of this air or the atmosphere around us, it exerts a force per unit area on every object on the earth. So that is known as the atmospheric pressure. So the atmospheric pressure is due to the force exerted by the weight of the air column on top of us or around us. Now the question comes, if we are under such a high pressure, why don't we feel it? It's because we have something known as a blood pressure. Okay, so the blood pressure equalizes the atmospheric pressure. So that's why we don't feel that immense pressure of atmosphere. So now comes the Pascal's law. So Pascal's law is related to the liquid pressure. Okay, so the Pascal in his law, he stated that whenever you apply a force in a confined liquid, it is transmitted equally and undiminished in all the direction. So what does it mean? Okay, so it means that like if I have a round bottom flask or such kind of device like this, okay, with a bulging part here, and I fit this with a piston. Sorry, it's a piston. Okay, so piston, what is a piston now? So I can press it. Okay, I can press it down. So piston is just like a pump that we use to pump our bicycle. So when we pump it, what happens? The air gets pressurized. But here I fill it this with the water. Okay, so it's completely filled with water, and then I have a piston fitted in it. Now I make several holes, A, B, C, D, E. Okay, so I make many holes. Now when you press it, you will observe that the pressure exerted at the point A will be transmitted to all the direction. When you press this one, it doesn't mean that the liquid will spill out only from the bottom. It spills out from here also, from here also, from this one also, from every hole, and that too with the same velocity or with the same pressure. So that is what it means. So the pressure exerted anywhere in a confined liquid, confined means in a closed container. In a closed container is transmitted, means I have applied a pressure at a point A, but it is transmitted to B, C, D, E, F, G, H, I. Okay, at every point, that also equally and undiminished. Undiminished means if I apply a pressure of 6 pascals here. Okay, so this will be transmitted undiminished means this 6 pascal is not going to reduce and become a 5 pascal. Okay, whatever pressure you apply, the same pressure will be exerted everywhere. Okay, so that is what the Pascal meant in his law. Okay, so the Pascal's law states that the force exerted anywhere in a confined liquid, it transmitted equally and undiminished in all the direction. Now there are some of the applications of the Pascal's law. So the Pascal's law is applied in a hydraulic press. Okay, and it's also used in lifting a heavy vehicles upward. You must have seen the JCB working. Okay, so in a JCB you will see the jack or like this kind of device. Okay, iron rod or a steel coming out from here. So you must have seen a small pipe coming out from here. Okay, so what does the engine do? The engine pumps in the liquid, and whatever the force the engine applies, it is transmitted equally and undiminished, and then there is a fluid known as a hydraulic fluid that pumps up. Okay, and then as a result the piston moves up away or it comes downward. Okay, so that is how the Pascal's law works in case of a hydraulic jack. So this is a very simple and easy chapter that is in your book. So go through your book once again, and if you have any problem, you can contact me in my WhatsApp number. Thank you.